Hello and welcome to Joe Cool's Reef series. This is a new series that I'm creating to talk about equipment and parameters of your reef tank. So stay with me, and over the series we will go over different things that we can do with your reef tank. Today we are going to talk about RODI systems. So as I said, we are talking about reverse osmosis and deionization systems. One of the most important things for your tank is crystal clear water. Zero TDS water is what you're going to want to mix your salt with. If you're not using zero TDS water, high quality water, then you'll be adding contaminants and organics to your tank. This is my system. It is a 6-stage, technically it's a 7-stage because I have 2 membranes on it. Now, to make your system the most efficient, you'll want the DI resin. And what this does is, after post-production of your RO unit, you still may have some TDS in your water. And what this does is it finalizes the water. Takes out the last bit of contaminants that is in the water that you can remove from the water to create zero TDS water. I have about 1 TDS after the unit, and then this takes it to 0. One thing to know about RO systems is if you're on city water, almost every city in America now uses a thing called chloramine. Chloramine is different than chlorine because it's cheaper for them to use and it goes a lot further. So if you have city water, you can go to your local government's website and look up their water testing parameters, and you can see if it's got chloramine in it. Good chances are that it does have chloramine in it. What you'll need is to make sure that your RO system has what's called catalytic carbon. What catalytic carbon does versus regular carbon is that it removes the chloramine from the water. Now, regular carbon can remove chloramine, but what happens is the carbon gets depleted way too fast. It's just not economical, and for what it costs to have catalytic carbon, it's the best way to go. So in the RO unit, you're going to want a good sediment filter. I recommend a 1 micron or a half micron. I use a half micron because the more you can get out before it goes through the rest of your system, the better. I have a half micron catalytic carbon for chloramines, and this isn't also a bad thing to have even if you don't have chloramines in your water, because it still takes different organics out of the water. And then a Chlor Plus block, and what this is it has sediment filter built into it, as well as a solid block for carbon to filter out your water. And this is a half micron, and they also make it in a 1 micron. So after it goes through this system and it takes out everything it can, it goes to the membranes. Now, what most of you don't realize is Film Tech and most membranes on the market are rated up to 150 psi. A lot of units have a really good rejection rate of 98% at 60 psi, but you got to realize that 98% is really not a lot. And you can make these membranes do a lot more if you add a booster pump. So say you have 70 psi coming in, you might think that's great, and it's not bad, but you're still wasting water and you're not using the full efficiency of the membrane. Some people say if you raise the pressure of the membrane, then you'll clog it prematurely. That is not true. Actually, the pressure causes it to filter out properly. There's reasons why they have these ratings. I currently run mine at about 130 psi, and I produce about 12.5 gallons per hour on a 75 gallon a day unit. Now, since I have the extra membrane, this is a 150 gallon day unit, but obviously I'm way gone over that. So if you want to make efficient water that's good quality, then you are going to want to have a decent RODI system, and I would seriously recommend getting a booster pump. Now my booster pump just so happened to come from Aqua FX. There are many great ones on the market, but this one just so happens has a adjustment screw here. You can adjust the pressure output of this pump so you don't go over 150 psi. They actually make one that boosts over this. That's a extreme booster pump. This one is just a standard flow, 0.48 gallons per minute to increase existing line pressure. It comes with a 80 psi shut-off switch, so when you shut it off, it shuts the pump off. And by using this system, a lot of people say to run this booster pump after all the filters and then right before the membrane. I actually just run it through the whole system. It's just easier to set up that way. I run the line coming into the booster pump and then into the RO system, and it's worked out fine for me. These systems are made to handle the pressure. There's no reason why you can't run 140 psi through this RO unit. I just assume filter everything out and have it that way. So when you increase the psi going through the membranes, you're increasing the rejection rate. So if you got 100 TDS and you're only getting 98, what's that tell you? You have 2 TDS coming out of the system. Now, most city water ranges from 100 on up. You know, I mean, if you got 400 TDS and 98% rejection rate, then you're going to have 8 TDS. So if you increase the rejection rate, which mine is 99 point, I haven't calculated it out, but it's pretty darn high because the TDS in my house is a few hundred coming in. So by increasing the pressure, you can create great water. I am producing 1 TDS before my DI resin. Now let me turn on the system. You'll hear the pump is running. You know, it shakes the lines a little bit. My gauge is stuck at the moment, so I can't really show you that. And then I have a TDS meter here. What you'll see is I have a 0 TDS coming out, and it just started, so you'll see the TDS start dropping. Now, when you're making water, it takes a few minutes for the system to produce a lower TDS water. So you have to give it some time. You do want to capture, generally you'll want to dump out the first gallon of water. It's really not necessary because it is going through your DI. A lot of people say flush your system before you send it out. See, I'm down to 2 at the moment. But it'll drop down to 1 here in a few moments as it gets producing. The pressure builds up in the system and the rejection rate increases. Okay, so I just tested the TDS going into the RO unit. It's 94. Now, I have an RO system on my well. I actually have a well system on the house, and I have an RO system for my water. So I haven't replaced my carbon or my catalytic carbon in my RODI system in quite some time. So it's possible that it's not doing its best. So you're going to want to keep up on that. You're not going to want to do as I did and wait so long. I'm sure once I replace that, since I have only 94 TDS coming in at the moment, that I should get a 0 on the end. But it still says 1. Okay, so that's about 99% rejection. You don't think that 1% is a lot, but it really is. like I said, these meters, their sensitivity is not in fractions. So if it's close to 1, it's going to say 1. It's kind of rounds it up. So it could be, half, 0.5 ppm. So this is just a good standard. Now, if it's close to 0 or 0, it's going to say 0. And as long as your DI resin, which I recommend using color changing, as you can see, I had a little bout of my system water coming in that had, I have a chlorination system on my RO system, and it got set a little too high, and it burned up a lot of my DI resin. Since I have a dual chamber, what I do is I wait for this one to color change. Once this blue gets a little less here, I'll switch this cartridge over, and then I'll fill this with new DI resin and put it in this one. So it goes in this one first and then into this one. You can see that it's working really well because this side has not been affected at all, color changing wise. So it's doing its job. But I'll report back once I've changed out the carbon and show you the difference. But you can achieve great water if you follow these parameters. Now, as far as production goes, by increasing the PSI, you're going to increase your production rate. Like I said, I have a 150 gallon a day system, but I can make 50 gallons. Look at that stream of water coming out of there. I can make 50 gallons of water in 4 hours. I mean, can your unit do that? Most units can't. Not with a dual membrane 150 gallon a day unit. So PSI is the key. Those ratings are based on 60 PSI, and that's what most membranes are rated to run with the rejection rate they give you. That does not mean that they are not supposed to run at that PSI. Now, if you look up your particular membrane, you'll see a max PSI. I don't recommend running it right at the max PSI, maybe 10-20 PSI lower, just because you don't want to damage the membrane. But they're definitely much more efficient to run that way. Okay, so I hope this video helped you out a little bit. I'm no professional videographer by any means, and I hope to make these more professional as the series goes on. But if you have any more questions, feel free to post on this thread and ask away. I'd be more than happy to help you. Some of you have concerns about what you do with your wastewater. I can help you with that based on whatever your pre-water is, so I can tell you how concentrated your post-water will be. Many people use it to water their gardens or their grass, but if you have saltwater intrusion or similar things like that, you got to realize that you're concentrating that, and that's what your output is. So most of the time I say send it down the sewer, which is terrible, but if you get a dual membrane system or a triple membrane system, you can greatly reduce the amount of wastewater you create. And with the higher rejection rates, you also create less wastewater. So if you have any more questions, feel free to post on this thread and I'll answer them as soon as I can. And I hope you enjoyed my video. This is Joe Cool out. Thanks for visiting No Limit Reef, and have a great day.